Hello, and welcome to the latest episode of Data Unchained. I'm your host, Molly Presley, and I'm excited for this week's episode to be inviting back the founder and CEO of Hammerspace, David Flynn.
Hi, Molly. Glad to be here.
Super to have you here. And it's fun as we kind of evolve the marketing and discussions around global data environments to have you come back on a regular basis and talk about what we're learning at Hammerspace about how global data environments are being adopted, where the technology gaps are that we're filling. So I think with that, we'll just jump right in and talk today a little bit about the cloud and how there's some evolution that needs to occur in technology to make the full potential of the cloud a reality. And so as we talk about that, I think one of the really interesting pieces that we've been talking about internally recently is the idea of why do cloud vendors, companies like Azure, AWS, Google, invite Hammerspace into deals? What is the gap that we're filling that really is causing them to lean in on bringing us into opportunities?
Yeah, I think it has to do with the cloud being able to live up to its promise. We think of cloud meaning you can, it's something nebulous out there. Nebula, get it? Haha. Cloud. Yeah, there's a pun there somewhere.
We have some imagery around nebulous there, I think, on the website.
it's supposed to be that you can run your workload anywhere. It's sort of this concept of a utility model of computing that you tap into it like the power grid and you run it wherever. But in reality, the cloud is quite the opposite. It's extremely centralized, monolithic. Once you choose the specific data center or region to house your data, that is where you're going to end up doing all of your processing.
So I know one of our recent guests was Eyal Waldman, who was the previous founder of Mellanox and, an investor, just kind of overall thought leader. I know you talked to him a little bit about, has the promise of the cloud been achieved? Are we there? Is there a gap? I think it would be fun to share kind of the conversation of.
Well, it's clear the cloud is having a massive positive impact, especially in today's world where supply chains are severely disrupted and where there's lots of chaos. Getting equipment and having the ability to outfit your own infrastructure is just not feasible. To go along with that, we're facing the end of Moore's law. It's getting ever harder to get a doubling of processing power. So that's leading to much more specialized processing, GPUs, special processors for artificial intelligence, and these custom pieces of hardware. It's not feasible for everybody to have their own. We have to pool these things so that we can get higher utilization of these resources.
So these resources are pooled. The way a cloud would set it up is in different regions, right? They have different services in different regions. Talk a little bit, if you would, about how we are helping to bring those different regions together and what that gap is between regions.
Well, it's very easy in the cloud to use an API, like say snap of a finger, snap of an API. You can spin up infrastructure. You can spin up a storage container. You can spin up servers that you need, and maybe specialized servers, as we were talking about. The real challenge is, though, how do you get your data there? So what we find is that customers find it difficult to exploit that potential of the cloud to be able to run anything anywhere because their data is not there. And data has mass. Data is massive. It takes a long time to move. And with that, you're left more siloed, stuck in monolithic in specific regions of the cloud.
What does Hammerspace specifically do that the cloud vendors, let's say Azure, does not? And I bring them up because I know they've spoken publicly about this as well. When you're talking about moving between different regions, what is it that Hammerspace is exactly doing?
In a way, you could think of it as virtualization. That's a term that people are familiar with. We're abstracting the data from the infrastructure and then empowering that data to be a decentralized resource. Of course, the way we do that is separating the metadata from the data. That metadata is very lightweight, very easy to aggressively replicate in all of the different regions of a cloud or across different cloud vendors or even your own private data centers. And that metadata then through the Hammerspace technology carries with it the transparent ability to access the data. So merely by having the metadata there, for all intents and purposes, you can now access the data as needed.
So the metadata sits separate from the data and can point to different regions depending on economics, availability, performance. Is that the right way to think about
That's
it?
That's right. And very importantly, the metadata is enhanced and is imbued with the ability to manage the data. So through metadata, you can manage where the data is physically resident across a highly decentralized infrastructure. So in a sense, to decentralize the cloud, to make the cloud into a true utility model of computing where you can run anything anywhere, you have to first decentralize data. And to decentralize data, you have to separate the metadata from the bulk of the data, empower that metadata to be replicated everywhere, and to bring with it the policy-based and on-demand-based mobility of data. So with that, you get the global data environment.
Okay, so that makes sense. Within a specific cloud or a specific cloud vendor, is there anything different when you want to take advantage of the same kind of capabilities across clouds or when you think of a multi-cloud environment?
Well, sure. The infrastructure itself is different with different APIs around storage. There's a lot of commonality, but differences in how you spin up containers and so forth. And the beauty about Hammerspace is that you don't have to worry about any of that. At the end of the day, you're accessing data through industry standard protocols in the same way across all of the clouds, across regardless of which public cloud vendor you choose. That uniformity makes it easier to pick and choose the venue where you want to run something.
I've always found it exciting when I see roadmaps and see what's going into new releases at Hammerspace on how quickly we're moving on integrating new cloud services, new integrations with new capabilities of the cloud. I think that has a lot to do with the development team that's been built here, but also the partnerships on the technology side with the cloud vendors. It's helping us to move really fast.
Everybody's facing that same challenge about data being very localized, siloed, and that need to decentralize it and have it work across any infrastructure means that we all have a similar interest in having data transcend the infrastructure.
We often get stuck talking about Amazon and Google and Azure as the cloud vendors, but when you think a little bit outside those three major ones, I think it would be interesting to talk about a few of the more, not even boutique, but different approaches to cloud. So Snowflake, we have an integration with Snowflake as well. Can you talk about kind of what the interest on the Snowflake side would be for doing that?
Well, Snowflake very interestingly talks about their technology as a data cloud, as a cloud, and it's generally for highly structured data, a big data warehouse in the sky where you can run things. But what we do that's so interesting is we make it possible to uplift large volumes of unstructured file data, say imagery or any type of rich media or whatever unstructured data. It's not necessarily broken into tables with specific schema. That unstructured data can now be stored as well within the Snowflake cloud.
And does the data have to move to the Snowflake cloud to take advantage of their processing and analytics capabilities, or can it still stay in the data center and take advantage of the applications that Snowflake has?
Well, see, that's the interesting thing about this notion of data orchestration and metadata-driven data orchestration. Is that the data may be orchestrated into Snowflake only temporarily so that it can be harvested for structure, for tags, for other information. And then that information can be reincorporated back into the unstructured data environment. So orchestration isn't necessarily a permanent thing. By its very nature, it means that the data can be transited through some processing step more than to be stored there. And so, yeah, that's absolutely right. This notion of metadata-driven data orchestration isn't just about moving data so that it's in the right data center on the right infrastructure. but it's also about potentially moving data through processing steps so that you can enhance that with other information.
I think that's a great observation related to really making data usable where and when. I think I've heard you say at the point of decision is a kind of an interesting statement. And it's not really just about storage or about data movement. It's about making it available to process and learn and use where you want it. And I love the partnerships that are going in place to make this possible.
Absolutely. And ultimately, it's about how we conceptualize data. And, we think about data as something separate from the storage storing it, and yet you can't really address it separate. With Hammerspace, what's really kind of counterintuitive is although we're abstracting data from that infrastructure, we're actually making data into something that is more real and more concrete, because now it is self-managed through its metadata, and that endures through time, independent of what infrastructure it's on at any given point in time or another. But we're seeing great partnerships like there with Snowflake as an example.
Yeah, and I think the Seagate partnership is a really interesting one too, as we shift this conversation talking a little bit about the hybrid environment. And I think Seagate is most well known as a hardware manufacturer, and now they're in the business of creating a cloud, Seagate Live, which has some interesting attributes about not having egress charges and things like that. But let's shift a little bit and talk about how Hammerspace works when there is no cloud involved, or when there's a data center and a cloud.
Well, if we think about it, cloud is really the concept of being able to consume things, again, be able to through an API and without care for exactly where. And at a certain scale, it can make sense for organizations to have their own infrastructure, either at a colo facility or whatnot. But to be able to run that as a cloud, as in through API, and be able to run anything anywhere and have it be this utility model of computing. Hammerspace, with the ability to present a global data environment through metadata, allows you to have a higher level consumption oriented abstraction layer, the consumption of data, as opposed to the consumption of infrastructure. And to have that across even your own private data centers, private facilities, and blend that transparently with the public cloud and with different regions of the public cloud.
As we look at the use cases of a lot of our customers, they need to use their resources and their assets efficiently. This benefit of being able to leverage what they already own, that maybe is in a data center, whether it's compute or storage, and then burst the cloud gets much easier with Hammerspace because of this orchestration.
You could say in some ways data being more permanent and often is an organization's crown jewels, there's a desire to keep it on their own infrastructure. Where processing being more transient, you want to be able to do that anywhere. So burst to cloud, where you're having it stored in your own infrastructure or at a place which is suitable for something that's so massive and can be expensive. So with Seagate, for example, this is clearly cost advantages given that they make the hard drives themselves. You want to be able to tap into that cost advantage and have the data where you feel secure with it.
So when you can't pick up a industry publication, really even a business publication, without hearing things about the edge, IoT. How do you see the edge incorporating into this whole story?
Well, when we talk about edge, you're often talking about where the data is getting collected or where it's being used to make decisions or to address a customer base, right? So edge is kind of the ultimate of decentralization, because now you're talking about every local region where data is ultimately being collected or distributed. So I think of it as kind of the logical conclusion. If you think about the big public clouds, if you think about the different regions of those public clouds around the globe, if you think about your private infrastructure that you want to run in a cloud-like fashion, your own private clouds and colo facilities and whatnot, and then even further distributed the edge. All of these concepts actually have something in common. They're all different aspects of a decentralized cloud, or really the distilled essence of the concept of cloud, which, as we're saying, is this concept of being able to use things through an API and not have to care exactly where, because just like I don't have to care where I plug in you know, my computer, which outlet, it's all the same. I've got horsepower coming through. The same thing ought to be the case when it comes to infrastructure. The infrastructure ought to be pluggable. It ought to not matter where. But we all know it matters a lot where, because of data and data having mass. That notion of data being centralized means that you end up stuck and having limited capability. And you can actually see this, by the way, even within a single cloud vendor. The fact that some regions of Azure, for example, are 30-40% less expensive than others for the exact same server instances, for the exact same CPU cycles and horsepower, exact same nodes. You're paying 30 or 40% more. And you have to ask, why should such a cost differential endure if it is like a utility and where you could run anything anywhere? And this is proof that it's not like a utility. And the reason for that is data. And it's very difficult to orchestrate data into disparate regions of the cloud. And so I would say that is a very quick way to put your thumb on what is the problem and the challenge. It's data.
That missing link really has been that data has had this mass or this gravity, which makes it difficult to move. And Hammerspace has overcome that by interacting with the metadata, which is light, and having really intelligent orchestration.
That's right. The first is metadata, which is inherently light. The second is using file granular orchestration and having that orchestration be based on policy so it can be done proactively in advance, and having it being done on demand, but most importantly, having it being done in a way where it doesn't interrupt the access. So now you don't have to take downtime. You don't have to reconfigure applications. While data is flowing in the background, you're already starting to use it. This same principles, by the way, is what went into, say, for example, container orchestration and Kubernetes' ability to distribute a microservice across servers. It's broken into the smallest units, lightest weight encapsulated, and then distributed across the servers. The same thing is what we do with data across the available storage infrastructure.
That's great. So when we think about this next generation of a decentralized cloud, as we kind of tie up this conversation, what do you see customers will do with it? What will be the benefit to organizations by having this final piece of the puzzle fall into the place?
Yeah. Well, when we take a step back, all of this comes to really one thing, and that's being able to do more with your data. And that branches into two. To do more with your data, you need your brain power, your people to be able to interact with it. And then you need applications and processing to be able to interact with it. So at the end of the day, enabling a distributed workforce, having brain power that is available anywhere in the world, and having processing power that is available in different places around the world, maybe because it's specialized processing, like we were talking about, to cope with the fact that that Moore's law is petering out. We need higher specialization in hardware. So really, this is about better utilization of resources, both brain power and processing power, and being able to work with ever larger data sets in a way that we get maximum utilization out of this infrastructure. Sharing the infrastructure with the cloud, but having a utility model where you can run things where appropriate. All of those things at their heart are dependent on the ability to move data to where you're going to need to work on it. And this goes against the conventional wisdom that has existed in the world of data and storage from day one, which is move the processing to your data. What we're saying here is the very opposite. We can no longer do that. We need to be able to move the data to where you have the processing capability, where you have the people. And that is now something that has to be globally available around the world.
And isn't moving the data kind of overcoming this long-held theory of the way it needs to work to something new? I think many people would wonder, but can you really? Aren't there network limitations? What has changed that now you can move the data to where the processing occurs?
Well, we have become much more interconnected with higher bandwidth, but we've also had large amounts of data. So at the end of the day, this comes down to being able to step into metadata, move things granularly and proactively, and be much smarter about how we utilize that bandwidth. Most importantly, not requiring that applications and users have to address things in a different fashion or find them in different places. We have to solve the namespace problem, so it's a uniform, consistent namespace. I like to talk about that as a single source of truth. We should decouple how people view the data and how they access it, how they address it, how they sort it and organize it should be decoupled from how it gets packed onto infrastructure. And that's not the case in the world where file systems are embedded within the storage infrastructure. That's the fundamental evil, which we can take up on another discussion, is this notion of the file system being embedded in the storage, because it's that scope that's fundamentally trapping you in with siloed data.
So we make the data available at wherever it's needed, whether that's a human, a computer, an application. Do that through light metadata, everyone interacting with the same view of data through metadata, and then intelligently only moving data when we need to.
That's right. Being very smart about how the data moves so it's granular and on demand. In other words, there has to be something between reactionary caching and moving entire and data migration projects where you're moving entire data sets, right? Caching is way too reactive, isn't really feasible over the long run, and moving whole data sets. With nothing in between, you're kind of out of luck. With Hammerspace, the ability to move files granularly on demand, it's much more sophisticated than caching. And with policy-based and proactive, things can move over time. So it's much more sophisticated than, say, a data migration project.
Got it. So I think unpacking the idea of a decentralized cloud and kind of the missing link in accomplishing the full potential of all the infrastructure and capabilities of a cloud was a great topic for today. I'd love to invite you back again to talk about a little bit more about this idea of embedded file systems and why we've innovated and spent so much time pulling that out of the storage system. So I think that'll be a great topic for your next visit.
Well, why it's taken so long to do something that should be on its face obvious, right?
Right. It's been something I know users have been asking for a very, very long time.
That's right. Well, I look forward to it.
Great. Thank you so much for joining today, David. Always appreciate having you on the show, and certainly your leadership here at Hammerspace.
Thanks. We'll talk to you soon.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.